Good morning, everyone. Today, I'm here to talk to you about failures, what they look like, how to prepare for them, and how to survive when they happen to you. My name is Ronnie Chen, and I'm an engineering manager at Twitter. Today, I'm here to speak to you as a technical diver. The first childhood memory that I can remember is standing on a small rowboat in a lake when I was about 2 years old. I stood up in the boat, and I saw some seaweed in the water, and I reached down to try to touch it, and I leaned too far and fell over the side. And then everything went dark. I lost consciousness in the water that day, and I almost drowned. And ever since then, I've had a healthy fear of water my entire life. Diving was a way to allow me to overcome that nervousness and safely explore the world that was underneath that surface. To help myself become more comfortable in the water, I took more and more training as I proceeded. I got my advanced certification, and then I became qualified as a rescue diver. And finally, I started technical training, which allowed me to go on deeper dives and safely explore shipwrecks deep under the ocean. In my first year, I did almost 200 dives. As I got more engrossed with diving, I started moving to using a rebreather instead of standard scuba equipment. A rebreather is a portable gas blending device that you carry on your back, which purifies the air that you breathe out so that you waste less gas. This is the same kind of life support technology that astronauts use in their spacesuits. And using a rebreather, I was able to do expeditions that lasted up to 5 hours on a single stretch and go even deeper than I was able to before. At 100 meters under the surface, your body is under 10 atmospheres of pressure. The nitrogen in the gas that you breathe behaves like a narcotic at that depth, and it slows down your brain, literally making you more stupid the deeper that you go. The gas that you breathe also builds up in your bloodstream, and if you swim up too quickly, those tiny bubbles will expand and cause decompression sickness, which can lead to muscle pain, dizziness, nausea, difficulty breathing, which is sometimes called the chokes, paralysis, internal bleeding, and even death. So if you want to return to the surface from being deep underwater, you have to stop many times on the way up so that the gas can slowly diffuse out of your bloodstream. Depending on how deep you dive and how long you stay, this can take several hours to achieve. And what all of this means is that in the case of an emergency, you cannot just swim up to the surface as a means of escape. Whatever problems that you encounter at depth, you need to solve at depth. There are many risks that you can encounter when you're diving on a rebreather, carrying as much as 9 kilos of equipment. I've listed a few here. I'm not going to go through all of them, but my personal favorite is number 12, which is that the material that is used to remove the carbon dioxide from the air that you breathe undergoes a chemical reaction when it's mixed with water. It turns into a caustic soda that will leave chemical burns inside of your mouth, airways, and lungs. So when you're diving in the ocean, which, by the way, is made of water, you might discover that your equipment has a leak in a very, very painful way. Underwater explorer Jill Heinerth quoted this statistic in a talk that she gave on rebreather safety when I first started tech diving several years ago. If you own a rebreather for 5 years, 2% of you are going to die on it. 5 years, 1% out of 50. When you are a diver facing these kinds of odds, your survival depends on your ability to persevere through a failure, because avoiding them is not an option. When we talk about failures, in our heads, we tend to think that they occur because someone did something wrong. One single event that causes a failure to happen. But that's a very simplistic and very harmful way to think about failure. If it was that simple, technical diving wouldn't be as dangerous as it is. Everybody already has redundant backups. We plan our dives and have additional buffers for all of our resources, our breathing gases. By the time you start advanced training, you already know how to survive simple failures. My first day of technical diving training in the pool, my instructor swam up to me while I was running a drill, and he turned off the air to my tank without any warning. I was busy running this exercise, and suddenly, I could not take another breath. How I would respond in those next moment would determine if I would be allowed to continue my training or be removed from the class. If I panicked, I would be a danger to my team and myself under the water. If I could figure out how to survive, then my lessons could continue. In the kind of environments that we would be exposed to, every person on the dive team needed to be able to deal with the possibility of deadly failures at any moment. In all of my years of diving, in the hundreds of dives that I've done, I have never encountered the same dive twice. The current was different. The visibility changed. The surge, the size of the waves, the amount of wind, the temperature of the water, the time of day, the time of year, the condition of my gear, my level of experience, how much sleep I got the night before, my fitness level, my state of mind. And then the people on my dive team, their state of mind, their gear, how all of these environmental effects affects them. There are thousands of tiny interactions that all contribute to every outcome, good or bad, on every dive. So no dive has ever been under the same conditions, no matter the location, no matter when I go. No failure, therefore, has ever been the same either. Here, I've listed some factors that contribute to a sample accident underwater. You start with a malfunction in your rebreather, which is a complicated piece of equipment that has many parts that can fail. And maybe you would have caught this failure if you didn't skip your pre-dive check, but maybe you were running late that day, you ran into traffic on your way to the boat, you weren't feeling well, and you just forgot to do this check. Your backup tank that is supposed to save you in this situation is running low because there's a leaky O-ring. Your buddy is distracted by something and doesn't realize that you're in trouble. The flashlight that you're using to try to get their attention doesn't work because you're diving in the daytime and the light has less contrast. All of this movement kicks up sand from the bottom of the ocean floor and the visibility drops. And in your panic, your consumption of air increases and you finish breathing the air that you have in your tank. And so you have no other alternatives except to swim to the surface, even though you have a decompression obligation. Now, this is actually a very typical of a diving accident at technical levels. And if you look, a change in any of these events could have stopped the cascade in its tracks and kept it from continuing into a fatal accident. But if you did a traditional root cause analysis where you tried to identify the trigger factor, how many of these other factors would you be able to identify? Change the time of day, change the visibility, change the fact that your partner was looking at a very interesting fish that came by at the moment when you needed help. And the story that you tell at the end of the day is very different. This O-ring that was leaking, was it because of a manufacturing defect? Or is it because you installed it improperly because you were in a hurry because you were late that day? If you do just a simple post-mortem analysis that blames this accident on that mechanical malfunction that started the cascade, you would only be covering 12.5% of the issues that contributed to this accident. If you focus just what is upstream of the starting incident, you are choosing to ignore all of the situational and behavioral factors that affected this outcome. Most of the time, in an actual accident analysis, we can't identify all of the contributing factors for a complex failure. And that's one of the definitions of complex systems. When the environment that you're operating in is so large, so complicated, that it's not possible for a single person to keep it in their head. So then, what does it even mean when we talk about safety in systems like this? Staying alive in this world requires us to prepare for failures and to manage them when they happen. If we can't prevent every trigger, we need to build safety systems that can stop these cascades from continuing. And if you want to do that reliably, there are some rules that you should follow. The number one rule of safety procedures, if you have a safety system, some operation, a way of backup, a checklist, something that is preventing failures from occurring, if they're not used as part of your standard operating procedure, they're not real. Don't run your backups, don't use your launch checklist, and those safety systems don't exist. Now, right now, you're probably wondering why I'm standing on the stage telling you something that seems very, very obvious. And the reason I'm doing that is because of something that the industry calls normalization of deviance. Normalization of deviance is that natural human tendency, especially in a pressure circumstance, to take a safety shortcut. Now, what is it that happens the first time that you take a shortcut? The first time as a diver, when you jump in the water without double-checking the amount of gas you have in your tank, because you just assume that the operator filled it up appropriately. Or the first time that you commit code for a new feature without writing tests. Most likely, nothing bad happened. Or the issue that it caused was small enough that it was easy and fast to fix. But the question is, how does that affect your judgment? The experience that you had reinforces the idea that the shortcut you took was okay. So the next time you're under pressure, you're going to try it again. And soon, this shortcut is the way that it's always done. I'm sure my code is right, so I'm going to push it to master without getting a review. I have a deploy checklist, and I skip this item because I know I don't need to do it. And then you take another shortcut somewhere else, and soon, you're not even using that checklist. If you continue in this way, your sense of acceptable risk becomes distorted, and your judgment becomes unreliable. And you've created pressure for everyone else to operate on these degraded processes. And at this point, the only thing that is keeping you and your team from failure is luck. Wait long enough, and your dependency on luck is going to create an accident. So, stop using your safety systems, and those procedures don't exist. If you have a passive safety system that you rely on, and you don't test it, that also doesn't exist. As the system evolves, configurations that used to work may no longer be appropriate. Your database backup works fine every day, every week. But one day, it gets so large that it's too big to be restored. If you're not testing if that backup actually works, you're not going to know that you don't have functioning backups until the day that you need it. Someone types an extra character in a config file that breaks the parser, and you're secretly running on default settings without knowing that it happens. In complex systems, components drift over time into an unsafe state, even if they were confirmed to be safe at the time that they were implemented. And this leads us to conclude that having unused and untested safety procedures can actually be more dangerous than not having them at all. If you know you don't have a safety net, you're going to take fewer risks. You're going to be more careful. The scariest time to realize that your safety system has failed is when you are relying on it to stop a failure cascade, to keep things from getting worse. If you read incidents analysis about failures, you're going to see this kind of behavior. We thought this was simple. We just restored from backup. And then we found out something really bad. So after you create a safety procedure or system, you need to test it. And then you need to keep testing it at regular intervals so you know that as your system evolves, it's still working. And the length of this interval should not be based just on how likely it is to fail, but also on how great the impact will be to you if it does fail. There are two ways that we commonly assess the riskiness of an endeavor. And the first and most common is that you make an assessment based on how likely it is to happen. The second one is based on the size of your regret if it does happen. If you are only evaluating risk based on the chances that it happens, you have to be prepared to experience the corresponding level of regret if it does. Low probability, high fatality accidents are something you have to be prepared for or accept that you're going to be one of that 50 in 5 years. Because if it's one thing that we know for certain in diving and in DevOps and all complex systems, it's that failures are going to happen. Complex systems are chaotic, they're full of interdependencies, and as they grow, they're going to build entanglements that are very difficult for anyone to map out and anticipate. So it's not just enough to build safety into your technology systems. You also have to build safety in your human systems. You have to prepare your people for the pressure situations that they're about to encounter. Pressure makes people bad at carrying out even really basic tasks. One of my first training tech drills combined two simple tasks that I was already very comfortable with and had trained it independently. One is an out-of-air situation where your buddy comes up to you and they have no more breathing gas. All you have to do is hand over your regulator and then put your backup in your mouth. The second is running a safety line, which allows you to come back through the entrance that you originally come in. You just hold the line in your hand, keep the tension on it, and walk. This was the first time that I was asked, while running a drill, to run another drill, a complex accident with multiple factors. Put them together, and I hit my cognitive limit. This person needs air, give them my regulator. As I'm putting my backup regulator in my mouth, I've released tension on the line, and now it's catching on my fins. I'm trying to catch my breath. My buddy's already headed for the exit. I'm trying to move to follow, but my flipper is tangled in the line, and I keep kicking my leg to get it free. I'm stuck. I'm breathing hard. The air gauge just keeps dropping. When I measured it, my air consumption in those moments actually tripled from when I was running each task individually. Because the simple act of combining two operations that I wasn't used to doing at once had overloaded what my human brain could handle. But practice this a few times in the classroom, and it was just simple, and I could keep going. When the pressure is on, being on call, managing an outage, having that muscle memory in your fingers, in your hands, actually takes load off of your brain. And you can retain mental CPU for critical decision making. Even a very detailed, excellent run book is not a match for exposure to the real process. A real run-through reduces the load on your brain when you're running a task. It allows your muscles to build up a memory of what you're doing, for you to build confidence and expertise, and allow you to practice operating under those kinds of pressure. A strategy that we use a lot in dive training to do this is having the least experienced person lead the dive. The whole team prepares together, but when we start the mission, the person who actually swims in front, is the least experienced member of the group. And experience in this case might mean fewest dives, has never done this kind of shipwreck before, has never swam and led in the amount of current before. The way for the mission to succeed in this case is to make sure that all of the members of the team are succeeding. And when I get to this slide, a lot of people tell me that this is where, in my talk, they feel most uncomfortable. And if this is you right now, I want to challenge you to spend a few moments to think about why this suggestion makes you feel that way, why you feel uncomfortable with the idea of the most inexperienced person leading. If the most experienced person leads, it's very easy to leave someone behind without meaning to. They just fall back and you don't notice because you're focused on the mission. If you want to increase the chances that everyone makes it back to the boat, your goal is to raise the floor of your operating capacity. In a failure, how bad it can get is determined not by the experience of your most experienced person, but by that floor. If it feels too risky to have an inexperienced person lead, that means that you've identified an area in your system that is not well protected against human error. But it's not just your inexperienced people that make errors. It's someone who's tired, who gets paged at 3 a.m. It's someone who has multiple failures that they're dealing with. Protecting a system for an inexperienced person and providing them with that training also protects that system against yourself when you're tired, when your operating capacity is degraded. And when you operate in this mode, there's a lot of hidden dependencies in your system that start to reveal themselves. Everything that you know when you're running an operation, when you're doing a deploy, when you're restoring from backup, everything, every secret warning that's not really critical, every command that you know that you need to run, every monitor that you need to look at that's not written in your run book, all of these things, all of these undocumented assumptions, all of these pieces of team history that you didn't know you had a dependency on will be revealed when someone else is leading and you are providing the safety system. If you fail to lift these new people up, you have to do everything by yourself. And that means you are a single point of failure within that team. The moment that you are compromised, the team's operating capacity drops to that floor of where everyone else is. So there's no resilience in your human system. But when everyone on your team has the experience to make mission-critical decisions, has been under pressure, and knows how to lead, your overall competency is raised. And every time you do this, it's also a chance to help your team build better judgment. Because complex systems are always evolving, the best weapon against failure that you have is judgment. All of the training, all of the rules, everything that we pass down in DevOps, that's a proxy for using your judgment. Training gives you a solution for a known problem, a defined set of circumstances. But when you understand the reasoning behind that training, you have a toolkit to solve entire categories of problems, and you can make decisions that better fit your current circumstance. As engineers, we need a lot of tools to develop better judgment in order to make better decisions. If you ever get a group of technical divers together, it's only a few moments before they all start swapping stories. But it's not just about bragging about the challenging dives that you've been on. It's also about understanding what kind of things can go wrong, how you can recover, and how to refine your decision-making skills in the moment, at 100 meters under the ocean, when your life depends on making the right call. So these are some tools that we use, both in DevOps and in diving, to build better judgment. Most of you here are already familiar with postmortems. But you need to remember that if your goal is to define a single root cause for your system failure, you're ignoring all of the other factors that have contributed to this. And those kinds of postmortems are good to give you an official reason for documentation purposes, to prove that you did your due diligence, but they're not an accurate representation of what happened, of all of the factors in the environment that contributed. And your real goal, if you want to get better and make your system safer, is to understand your system and address its weak points. So take the time to look not just at the factor that triggered the event, but all of the things that happened or maybe didn't happen that allowed your failure to continue. And you don't need to wait for failures to happen to start doing this kind of work. Before every dive, we discuss some of the risks that we might encounter, and we talk through how we can combat them. What happens if we end a dive early? What happens if the visibility is very bad and you can't see your partner? What happens if you do a rollout that takes 8 hours to run on all of your servers and 30 minutes in, something goes wrong? What are your options? What is possible? If you talk about these strategies ahead of time, that'll help prepare you for when the pressure is really on. And in order to practice for that kind of pressure, you can do something called a fire drill. Running a fire drill is a way to simulate accidents and incidents to make sure that your plans and safety systems are functional. The first time you do this, start with the basics. Follow the runbook and just verify that it does what it claims to do. Establish baseline confidence in your simple failure recovery. And then start building on the complexity. Introduce more failures. Introduce multiple simultaneous failures. One of the ways that you can do this is to designate someone on your team as an arsonist to start that fire. Create a failure scenario and evaluate your team response. Can you rely on your monitoring and system awareness to diagnose the issue? Do you know what to do once you've identified the problem? Are the tools that you have sufficient to resolve the issue? What training gaps do you identify as you go through this process? And start these drills in the safety of a pool or test environment before you start creating failures in the ocean, in prod. When we look back on our actions after the fact, after the deploy, after the launch, after the dive, we have a tendency to look at the cases where a failure happened, the postmortems. When everything goes well, we tend to just move on. But it's really important to revisit your successful operations as well. Not just to learn what went well and to encourage it to grow in your environment, in your culture, but also because as humans, we have survivorship bias, which means that we assume if nothing bad happened, then the decisions that you made were correct. But you've built a system that has a dependency, a hard dependency on luck. And so you want to identify places where luck prevented something from going wrong. And that's what helps you to identify and fix the safety shortcuts that are lurking in your systems. Places where there was normalization of deviance and you just haven't been bitten by that failure yet. For example, I finished my dive with absolutely no problems. But what I didn't plan on was that the heavy current would affect how much air that I would need. And as a result, by the time I surfaced, I have nothing in reserve, no buffer left. So if something else had gone wrong, I would have been in serious trouble. What does that teach me about my next dive? What conditions do I have to monitor for? Just something that simple, sharing that thought process with other people teaches them what factors to account for in the future and allows you all to make your judgment even better. Finally, the last thing I want to talk to you today about is success. In diving, the best rescue is the one that you never had to do. The best incident response is when you don't have an incident at all. When you first start diving, it's very common for you to get in trouble and need a rescue. And then, as you get better, you learn how to do rescues. But finally, you build up the judgment to avoid situations that would require a rescue in the first place. Our culture has a tendency to reward heroic action. But that's based on a response to failure. It's really important to recognize that real success lies in doing a job quietly, without incident, day after day. When a failure is boring and routine, we usually don't recognize that. Nobody gets pizza and sent home early because a system didn't go down. But we do the exact opposite all the time. And so we need to remember to reward success, especially the kind that is boring and routine. If you're interested in learning more about how complex systems fail and how to manage those failures, these are some links that I recommend to get started from other industries. That's all I have for you today. I hope I gave you some ideas on how to make the work that you do a little bit safer. Thank you for listening, and stay safe out there.